Welcome everyone. We have our monthly webinar today on Friday, 3rd of April 2020. This webinar is about radio frequency energy harvesting in the age of IoT devices. And the host is our community member from NOCO, Collabwith, Murad Eskiyerli. Welcome, Murad.
Thank you, Yara. Thanks a lot, and thanks for giving me this opportunity. And when Yara asked me to give this webinar, and because it's really something I've been working with for quite a long time now, well, I was worried that I could find enough technology beyond RFID and so on. But actually, I noticed that even within my network, a lot of people are working now in RF energy harvesting, and for good reason. Before starting, I would like to once again thank Yara and NOCO community, because NOCO has been doing some wonderful work on bringing innovation as a service to bring academia, startups, and companies to increase collaboration, reduce bureaucracy, and match them with the business needs and challenges. And of course, Jara once again is here with us, and please take any questions during the webinar and afterwards. So please do not hesitate to contact her for anything about the NOCO community and the services it could provide. This agenda is basically our agenda. Of course, we want to know what IoT devices is. Although in the last few years it has been sort of flavor of the year, where everybody is talking about IoT. Seeing that like artificial intelligence is going a little bit off the buzz has quietened, but I'm sure now once the buzz sort of dies down, we'll see even more applications. But it has come a long way in the last 10 years, and now it is an established part of our life. Although there's a lot of marketing speak, smart this, smart that, still it will be everywhere. And I think it is fair to say that for each person we'll have about 10 to 20 smart devices, IoT devices, which means that in next 10 years we'll have around 150 billion IoT devices. And of course, that is a big challenge in many levels, so we'll be touching of some of these problems we'll be facing. And of course, like everything else in life, we have to power that, these IoT nodes, IoT devices. In this presentation, nodes and devices will be used interchangeably as needed, but they basically mean the same thing. When we call IoT nodes, really we mean that the smaller devices that are communicating with each other, or some base stations, some central location. We'll be coming to that point. We'll return to that point later again. Of course, batteries is easiest. I mean, batteries have been with us for more than a century now, since the pioneering examples of Alessandro Volta. But the point is, batteries have their downsides as well. So we'll be looking at some of the alternatives to batteries, especially, of course, the subject of this webinar, RF energy harvesting context. RF energy harvesting, of course, is not the only methodology, but it seems to be that one of the main ones, because other methods will have their downsides and don't even have that much availability. We'll be going through some interesting examples of RF energy harvesting. I especially chosen 4 examples. Why? well because I knew them. I mean, I know the founders more or less, either as friends, partners, or customers. But there are many more, and I wouldn't be able to tell you more about this subject, this field in an hour. But I hope this gives you a taste of the level of technology and its direction. And we'll be talking a little bit about technical hurdles. There's an old saying: every time you show an equation in a meeting, in a presentation, you lose half your audience. So I'm not going to go through equations here, but anybody is welcome to look at our company, Revolution Semiconductor's website. There is much more information there if you are more technically inclined. So let's start with the description of Internet of Things. Well, Internet, I'm gonna maybe telling you about my age, but first time I ever heard of Internet was '89. I was a university student, and Internet has not come. I'm Turkish, so Internet has not come to Turkey, but something else called BitNet. It was '88 or '89 that come, and you would have to have this. You would have to have some bridges to this Internet, because an Internet has its own book, so you could check the book and see if an institution is connected to Internet or not. But Internet really started as a people-oriented system. So you could send emails. Email was the first killer application, maybe FTP, but both creator and user of content were people. So, of course, Internet created a huge new economy, new products, new services, and of course, new time wasters in the last quarter century. And I think it is open to debate that has Internet really increased the productivity at the end. And there was a joke in Dilbert where Dilbert claims that he calculated the productivity improvement thanks to Internet, and it is zero, because everything you gain through Internet, actually you lose through Internet again. But still, everything so far done up to last 10 years was really for people in Internet. But the world we've been in industrial age since late, mid 19th century, let's say, and machines are everywhere. And machines have been quite dumb up until recently. And that was good because you could get your car checked, for example, by a mechanic quite easily. It was a mechanical device. He will go to, you'll take your car to his workshop. He will open it, check the engine. If something is not working, he'll be able to fix it. Well, nowadays, it's not that easy. Actually, even cars are basically a mini internet. Basically, I've been reading that a car's third most expensive item is the networking inside the car. So this is one aspect. So all the machines are getting not smarter maybe, but more network. So they're exchanging data. But we can go one step further. I mean, it doesn't have to be a car. It could be environment where these machines could be talking to each other to make our life easier and bring in more data. And of course, that avalanche of data thanks to these small nodes in the ambient, in the environment, brought its own buzzword, big data, but we won't be going into that. But reality is that now we do have so many small devices all around us, and increasing numbers that is that are talking, they are networking. And so initially the, the term that was coined for such communications were machine-to-machine communications. But machine-to-machine communications didn't really cover whole extent of such devices communications, because at some point these devices are actually using our internet network. So, and data they provide is being used by people to make better decisions, to improve the lives of other people, and maybe lives of the IoT nodes. So that's, I'm not going to get into the science fiction aspects of the future, but it is obvious that Internet of Things are here to stay, which bring their own challenges. Now, we all know Facebook, although I canceled my account about 1.5 years ago, and it really did wonders for me. But anyway, people are data hooked. Each Facebook session, apparently, there's a few years old data is using about 80 megabytes per hour. But Internet of Things devices are different. It could be a sensor, maybe a few sensors together. I mean, I put a picture of an interesting application where a parking sensor placed within the pavement, within the asphalt, let's say, just checks if a car is parked at that parking slot, and then if a car is parked, it says, well, somebody parked on me, not, and then this data is aggregated and shared with the drivers in a city. Why? Because up to 1/3 of the traffic in the busiest centers, downtowns in North American parlance, is due to people looking for parking slots. So if you can make the people's, can bring the information to people saying that, well, these are where the parking slots are available, parking places are available, you'll cut down on those drives, which means that less environmental pollution, less gas consumption, and overall cleaner, quieter city center. So that's very good. Well, what is the downside? Let's say that a city wants to install one of these parking sensors. Well, you have to drill the ground. You have to, as you see, you have to put it in the ground. Then maybe let's assume that you have 20,000 of them in the city, and a month later, battery dies. So you have to send someone in all parking slots and get the battery change. So that's not feasible, because especially where such solutions are needed, for example, for this example, labor is expensive, it is dangerous, and you will be basically losing all the advantage you are gaining by installing such IoT devices. Then what is the solution? I mean, well, you could wire them, but wiring in such difficult, hard to reach place is not that feasible. You could try batteries, but then you will have your own problems. Before going that, I want to just reiterate the characteristics of IoT devices. By the way, you are free to interrupt me if you don't understand about what I'm talking, or you have any questions, to interrupt me, no problem at all. As the last example showed, IoT devices could be in hard to reach places. So they are difficult to replace and service, as we touched in a moment ago. We can't wire them easily, and then the communication really has to happen through wireless technologies. So that is, that is why you have various Wi-Fi, Bluetooth, and some other technologies. We'll be touching that in a moment, to be being used for communicating with IoT nodes. Another point is that they need to, many times, they are not like computer or something else that mainly be used by people. They are used to sense their environment. A moment ago, we saw that the simple parking sensor was used to see if a car parked on top of it. Maybe another IoT device will be checking the air quality. Another one will be checking the temperature, or whatever. There are countless applications, and they need to basically able to communicate these data periodically to whoever is collecting data. It could be base station, it could be aggregated with other data from other nodes. So you might end up tens of thousands, even millions of nodes in the environment, and each will have to communicate the data periodically. But those data are not large. I mean, it could be maybe that a moment ago we gave the example of a parking sensor, and it might be just, there's my name is this, my number is this, and there's a car here or not, and maybe time. So you might think that it's more like an SMS where there you have about 140 bytes. That's a good example. So but that would be infrequent, either periodically or sometimes when they are queried. So data communicated by each IoT node is usually quite low, but if you think about there are tens of thousands of them or millions, as the case would be, then they have their own solution in wireless. And so there could be different solutions for networking such IoT nodes. Some of them are low power wide area networks. There are different solutions, weightless, Sigfox, and usually their range is quite long. It is like up to 10 kilometers maybe, and they are really oriented towards these IoT nodes, which are communicating huge, small chunks of data infrequently. I mean, Sigfox, for example, expect IoT nodes will be talking once or twice every day. And others are a little bit more frequent data communication. They assume the data will be communicated a bit more frequently. And then if you want to go for lower data ranges, then you could use this what's called wireless local area network type solutions. Of course, Wi-Fi, Zigbee, which will be useful up to 500 meters, especially with the newer Wi-Fi standards, which are especially created for IoT type applications. And then you will have Bluetooth, which might be really useful up to 100 meters, and then different communications, which could be useful at most about 20 centimeters. But the question still remains, how do you power an IoT node? I think that device is, again, the device in the picture is a low power wide area type node. As I said, changing the batteries of IoT node frequently is not not a meaningful acquisition. So the holy grail is that having a 10 years maintenance-free useful life. Well, beyond 10 years, a lot of things get, people accept that, 10 years is a good time. And whoever has ordered these IoT nodes will probably have changed jobs or have retired. So that's why I think where 10 years is coming from. So 10 years, people find a meaningful yardstick. But what about batteries? And we have battery-dense systems that will have enough capacity to charge to power our IoT nodes. That is the big problem. Now let's consider this system again. The battery in that picture is what is called ER34615 in industry. So it has a rated output voltage of 3.6 volt. Capacity is quite large for a battery, 19 ampere hour, which is so, and weight is 100 grams. It's quite heavy for a small IoT node. And the price in volume is 15 euros. That is expensive because once you think that you want to have, let's say, order 10,000 of these nodes, you are already ordering $150,000 worth of batteries, and they are quite heavy. They are expensive, and they are large. But does it solve our problem? And let's think that we are not even using low power wide area network. We are using a Bluetooth. And a Bluetooth transceiver, a typical one I picked, has 4.6 milliampere current consumption in TX transmit and receive modes. That's a typical one. There could be lower ones, but that wouldn't change that. Such a large battery would be only enough to charge for continuous operation of the Bluetooth transceiver for about 6 months. But we are talking about 10 years, which is about 20 times larger than operation time than this battery can supply. Well, the solution is, of course, turn off this battery, turn off the transceiver when we are not using it, because we always said that we haven't, we don't need these IoT devices communicating all the time. But of course, it brings its own headache, where basically you have to synchronize all these devices and make sure that even when you turn it off, you are not wasting power. So it has its own challenges. What about 10 years later? You end up with the batteries large, dirty, and actually use quite rare metals like lithium, magnesium, some other materials which are difficult to recycle and difficult to manage. So we know that battery materials are getting more expensive. So we establish more or less that a battery may not be the best solution most of the time. What could be the alternative? The alternative is that look for energy around, in the ambience. And ambient energy, of course, light is sunlight. It is periodical. During the daytime, yeah, you have some sunlight. And but in northern climates, well, you wish for it. Maybe global warming will change that. Then you could think about artificial lighting. Again, the same problem. And I suspect with the LED lighting and everything, it may not be such so good anymore. Could think about ambient noise. It's a kind of vibration. So you might want to use ambient noise, but it's energy density very low. And of course, we'll be touching that and we'll be exploring that more fully in a few minutes. radio frequency energy. You could think about thermal energy, but the thermal energy cannot be used by itself. It has to, you have to have a gradient. So some parts will be warmer, some parts will be cooler. Otherwise, it's very difficult to use. And then mechanical movements, again, like vibration. If that IoT node, that is constantly in a machine that's constantly rotating, moving, and so on, you could think of using that mechanical movements in power your IoT nodes. Now, we are able to start this RF energy harvesting subject. Finally, I suspect you get a bit bored with all this explanation, but I want to give you an idea about why we are even bothering to investigate RF energy harvesting. Actually, we'll be finding out in a minute that it's not that easy. So, if RF energy harvesting could realize, we can get rid of the batteries, could just place our IoT devices somewhere, and they will be happily getting energy from ether, from the air around, from ambience, and will be happily living ever after. So, but that's not that easy. So actually, if you look at all the RF energy harvesting systems, there are two kinds. One, a lot of them are actually using dedicated transmitters. So there's a transmitter somewhere that is powering our devices. And now the real holy grail of the subject of the field is ambient RF energy harvesting. We'll be touching both applications in a moment. Ambient RF energy harvesting really is trying to scavenge the power in the RF transmitters around us. We start with the cellular phone, 2G, 3G, 4G, and now 5G. And of course, ubiquitous Wi-Fi access points, Bluetooth in all our phones, and maybe other wireless transmitters. And of course, I don't hear that much around nowadays, but there used to be scares 10 years ago about all this energy emitted by our mobile phones. There were SAR values being bandied around. I don't hear about it anymore. But this gives you an example idea about that. Yes, there are quite strong transmitters in our phones and the associated base stations. And actually, if you think about your phone, a base station could be maybe up to 10 kilometers away, and you are still able to communicate and exchange data. There's a lot of RF energy, but that's not that simple. Why? Because a lot of calls are being made during the day, maybe nighttime. You don't have that many calls. You might be close to a base station or another mobile phone, maybe not. You might have obstacles in between your base station and your IoT device. Maybe there could be a hill, a building. And for data communication, yes, you could be still okay, but obstacles could cause fading, what is called in technical, basically you might end up in a location somehow there isn't that much RF energy. It might be enough to make a call, but it may not be enough to power your device. Now, frequency is another matter. Now, I've been checking the number of the frequencies being used in RF harvesting systems. And a lot of data is actually from 5, 6, 7 years ago when there is still mostly 2G, 2.5G systems. And with the 3G, 4G, and now 5G, although 5G is more of a gossip than reality, even 4G, first the frequencies being used change. More frequencies were open for mobile communications, but which means that older frequencies are not used that much. Even some countries now retire 2G, so those frequencies are either used for other applications, or even if they are used, probably energy profile of those bands have changed. So that's a problem. Then atmospheric conditions, for example, rain is usually quite bad, unless for lower frequencies, quite bad for RF signals. And you may not notice it with your in communications, but energy really drops. So I look at this, some numbers, ambient RF power density. Most recent studies show somewhere between 14.5 dBm per meter square or 54.5 dBm per centimeter square, which means that if you have a antenna size of a mobile phone, you will be still about, will be able to get data theoretically, data energy 1,000 times less than a typical RFID tag is using. So ambient RF power energy harvesting is difficult. But some people attempted that, so I want to give you an example. Clean space tag is because it seems that the company behind it changed direction and no longer is manufacturing these tags. But that was a very good example. That device came out of the research done at Imperial College London, and it had an onboard carbon monoxide sensor, and it had an onboard Bluetooth transceiver to communicate a smartphone. And their claim was that they were harvesting energy at GSM 1800, 1.8 GHz band, and Wi-Fi. And still, it has an onboard battery to power it. So they will be using this ambient RF energy harvesting to charge their battery, but battery will become already charged. So idea was that you'll be, they will be working in combination. So I'll be going to a short, I took a clip of a much longer talk with the Mr. Drayson from the company's owner about their technology, and I hope it proves to be useful.
I mean, for instance, that doesn't have a battery and you never need to charge it. Well, it has a battery. Oh, it does have a battery. But it's trickle charged. Right. It has a very small storage. You don't have to change the battery. No. You don't have to plug it in to charge it. And that's one of the things we've got live is there are so many electronic devices. You go on more to plug in, which you need a battery for. And, we just experienced that. Yeah. There's a bit of a problem with the sound equipment. We'll say no more. But this is now constantly getting a little bit of electricity from the air around it, which is just extraordinary. So, and in particular from Wi-Fi networks and 2G cellular networks. Right. So those two bands. So the harvester, which is a type of antenna, which is inside the device, it's harvesting energy from those parts of the electronic spectrum. So it's not everything. So Wi-Fi and 2G cellular. And we're talking about very small amounts of energy. You remember in the Faraday lecture, we measured it with the probe, and we had hundreds of nanowatts per square centimeter. Just going around the room. Yeah, and so we see this as a great way to power small electronic devices.
Oh, sorry. I want to show something.
Which I just had.
Remember
in
the
Faraday lecture, we measured it with the probe and saw that we had hundreds.
That's an interesting plot. I want to get your attention. Actually, they measured the RF energy profile, and that was a nanowatt. Okay, that's sorry. Okay.
and talking about very small amounts of the electricity with the probe, and sort of we had hundreds of nanowatts as well as around the room.
Sorry, I'm not going to attempt that anymore because it seems that Mr. Microsoft has decided not to collaborate. But important point here is that ultimately.
More and more connected devices, particularly sensitive, where you can really change the philosophy rather than in the case of measuring air pollution, where you have a small number of very expensive sensors maintained and owned by the government, obviously, and then you do computer modeling of the expected pollution between those small numbers of sensors through a technique where you have many, many more sensors which are accurately reading what's happening where they are, and then
okay. So I clicked that side. I mean, there are two important pieces of information for me from this clip. One was that they measured at one point the energy, ambient energy profile of a location, and they found that 1.8 gigahertz and 2.4 gigahertz were at the most energy. But I suspect if you were to measure now here in Netherlands, we might not find the same energy or frequency profile. So that is one of the biggest hurdles with RF energy, ambient RF energy harvesting, where you are really dependent on ever-changing profile of ambient RF power. And the second thing is that Paul Drayson was explaining very well that why we want all these IoT devices. Basically, instead of taking, for example, 1 or 2 carbon monoxide measures in discrete locations, you could have many more measurements by using these RF energy harvesting IoT nodes. So the vision is right, but I'm sorry to report that that device is no longer for sale, and companies seem to have changed the orientation towards more to smart, payment cards and so on. I don't know why, but it gives you an example, very good example about the potential and pitfalls of ambient RF energy harvesting. Now let's go to RF energy harvesting from a dedicated transmitter, because that is something much more widespread. And if you look at the examples that is in the Mars space applications, that's what we've been using for a long time. Of course, RF item tags in the shops is a very good example. If you go to a lot of shops nowadays, you'll be finding RFID item tags. Some of them are what we call high frequency, and some of them ultra high frequency. And UHF ones, ultra high frequency ones, are good because they can be used to take the inventory of a shop maybe in a few minutes. We'll be coming to that. Another one is the contactless smart cars. Again, these are the high frequency ones, but they really use the magnetic fields instead of electromagnetic waves to harvest the energy. And another application, again, very similar technology in some respects, the contactless smart cars, the wireless phone chargers with their dedicated ports. Never used one, but I've seen people using it happily. But I want to give two examples, recent examples that are pushed by 2 US startups. One is Atmosic Technologies Bluetooth transceivers. Another one is Groove Wireless over-the-air phone chargers. And they are both using dedicated transmitters. Now, if you remember, we talk about the transceiver, and really we had to pair it for a long time operation with a large, heavy, expensive battery. But another a US startup called Atmosic Technologies want to eliminate these batteries in IoT nodes in enclosed space. An enclosed space could be a room, and we'll be seeing in a moment. But it requires a dedicated RF, close-by RF transmitter to power these nodes. So you could have a few pieces of equipment with their own Bluetooth transceivers in a node, in a room, and they will be all powered by a dedicated RF transmitter in the same room. So it's really suitable not for IoT in the environment, in the larger environment, open spaces, but really in a room. Well, which is still useful because a lot of IoT examples, applications are for smart home, smart offices. So that could be still a big change in reducing the need for batteries. So I'll be going to another video that's company supplied.
Power wireless connection on battery and solely on harvester. This keyboard contains our Bluetooth line featuring our MP3 chip that enables energy harvesting. This is the RF80 source connected to the USB port that powers the keyboard. I'm going to remove the batteries that typically power the keyboard. You can see I'm typing with the keyboard now. Powered solely by the MP3 chip with energy harvesting.
Okay. Atmosic Technologies is really a cheap semiconductor company, and they really want to use their Bluetooth transceivers taken by manufacturers in creating batteryless IoT nodes in enclosed space. It's way too early to talk about whether they will be successful or not, but that's an interesting example. Another company, it is Atmosic from Northern California, grew wireless from Southern California. And done as a result, this company was created as a result of research done in California Institute of Technology, is using dedicated RF transmitters to charge mobile phone devices. So they want to use their dedicated transmitter and dedicated receivers, and you could see in the background a picture of the receiver antenna to be able to charge the phones wirelessly in a room. The difference is that there is an interesting technology. It is using much higher frequencies, 20 gigahertz or higher, which is about 10 times higher than the Bluetooth example we gave in a moment ago in Atmosic case. And they are focusing their energy using what they call RF lenses. In a typical startup fashion, they are not divulging too much about their technology. But looking at their boards, it is reasonable to assume that they are using beamforming, using phase array transmit and receive antennas. So that is actually the same technology now being used in 5G and maybe radars to focus the beams RF energy in one direction. I'll be again showing a short video about their technology. It is a part of a clip of a much longer video, but it gives an idea about what they are trying to accomplish. Laptop, cell phone, and so on, and the room system will accomplish the same thing with a different form factor on the
algorithms and technology, we're able to actually deliver significant amounts of power.
Okay, sorry, my apologies to this gentleman. I interrupted him half sentence. So the idea is that you will want to charge your phone using these devices in short distances. The quoted length is about 10 to 20 feet, which is about 3 to 6 meters. Well, I have my doubts about if there is a market for that, but it's not for, I'm somebody who said that when I first saw Google that maybe they wouldn't be successful, but that's another story. Now let's look at the one much more successful, much more established application of RF energy harvesting, and these are UHF passive RFID tags. Actually, it's the same idea as the examples we've seen a moment ago, both Atmosic and Blue Wireless. But they are using a low frequency around 850 to 950 megahertz. But their application is they really started to the idea was to replace barcodes. Barcodes have their own dedicated readers. They're optical. They are very cheap. A barcode printing a barcode is really nothing. A little bit ink. So it wasn't very successful at the start because the infrastructure there, the readers were expensive, tags were not very cheap, maybe 20 cents. So it could be only used for more expensive tracking, more expensive items. But in the last 10 years, we are seeing now the same technology base being used in many different applications. For example, toll collection motorways, wireless device configuration, and powering battery-free sensors. And we'll be coming to giving another example on this subject. So UHF RFID again obtains its power from a dedicated RFID transmitter. It is called an RFID reader because it both powers the tag and communicates with it. Range is limited by the need to power RFID receiver. And the best case is less than 12 meters. I mean, that is a manufacturer quoted number. Usually in real life is 5-6 meters. But this is quite good for many applications. If you are in a shop and you want to take an inventory and you have all these clothing items, a shop attendant could use a handheld RFID reader and read all these tags, all these items in a few minutes, a few seconds actually. Sometimes RFID chips still have a battery to extend reading range, but these are outside of our purview at the moment. And tags transmit data to reader by backscattering, which is basically because they don't have much power on themselves, they either scatter the RF power coming to them or they don't, and it is up to RFID reader to sense the change. In the background, you see a typical read-write sequence and the waves in RFID tag. This is from a chip designed by Revolution Semiconductor, our company. Again, the power budgets are very low. We are talking about tens of microwatts, even lower, when you are reading, when they are read by a RFID reader. And it has its own problems. For example, to transmit the data transmit data to a tag, reader usually uses pulse interval encoding with amplitude shifting modulation, which means that actually up to 30 microseconds, RFID tag is receiving very little power. Again, the power on RFID chip will be stored on chip capacitors, and the chip will be using power stored in RFID, these capacitors. So that's quite a difficult question, not very easy to realize, but there are many successful examples in the marketplace. I'll be giving you an example of P-Crystal, which is went beyond a simple RFID tag for item inventories and so on. They want to combine a flexible tag using the manufactured using organic semiconductors with a sensor. And they license actually RFID designs because their main focus is really in manufacturing organic semiconductors. They've been still going strong, and they want to do, for example, pressure sensors and other sensors, strain sensors. And there is another Spanish company, again, working on combining RFID tags with sensors, because if you want to measure some environment, you just power your RFID tag and then read the data and leave it there until next time you read it. Now, I want to touch at the technical hurdles. I mean, if you look at the literature in RF energy harvesting systems, it is getting bigger and bigger. And then really, it is an antenna combined an RF to DC rectifier. And you have to co-design, you have to design them together. And actually, frequently, they are called a rectangle. Don't ask me why. It's strange, but anyway, it should be actually antenna should be the first, because first antenna, then rectifier. But anyway, this is quite difficult to realize and design, because when I talk to people in the field, my colleagues, but who are not working on this specific field, they will think that we are doing RF design. Actually, it's not RF design, because unlike the RF communication systems, we are not really talking to very small signals. Actually, signals are large, but you want to, compare it to RF communication signals, but you want to extract as much energy from the incoming RF wave. And so power matching techniques are not very useful. You need to really concentrate on extracting as much energy as possible, as much as possible, over a period of RF signal. Obtaining out these voltages higher than 0.8 volt is hard and inefficient. You have to plot in the background, and you can find this in our website as well. I'll be giving you links in a moment. So getting an output voltage, we just a moment ago we talked about minus 20 dBm, 25, minus 15 dBm, minus 20 dBm powers, densities in a meter square. So assume that you have quite a large antenna. Even with them, obtaining output power more than 1 volt is not very easy and not very efficient. There are companies who are working over this. They claim that they have solutions, probably using charge pumps and everything else, but it is still an active area of research. And as you've seen in the clean space tag example, I look at their website. I look at they selling their tags over Amazon, and 30 to 40% of the reviews were very good. Another 30% were 1 star because people couldn't get it to power. So it really is touch and go still. So there is still a way to go using, designing and realizing RF energy harvesting systems especially for ambient RF energy harvesting. Now, another interesting technology avenue in front of us for anyone to investigate. Remember, the group wireless was using beamforming, and the same beamforming technology is now being used in a much larger scale for 5G cellular technology. So can we imagine that 5G technology will be used for powering the remote devices in the base station, around base station? Maybe. So maybe cellular operators, Vodafone could be energy supply for IoT devices in the future. We don't know. But that could be an example of future I could imagine. As I said, RF energy harvesting is here to stay. We are using it every day, and batteries are expensive. The economy hasn't changed. Batteries are not getting very cheap easily, except for Tesla hype, and I want to see the owners in 5 years' time. But there is still not, we don't have a killer application. And RF energy harvesting requires a deep understanding of co-design of antennas and RFDC rectifiers, and ultra-low power integrated circuit design techniques if you want to use ICs, and most probably you have to. The last slide from my side, I tried to give an overview of RF energy harvesting. As I said, co-design of antenna with RFDC rectifier is crucial, and this is something that will be better and better over time. Company Revolution Semiconductor has done in the past and working on this field. As I said in the beginning, I didn't want to go into too technical details, but if you are interested in understanding the subject any further, there is a presentation which was done in IEEE RFID conference, exactly the same subject, and there is a white paper again. You can find the links in our website in www.revsemi.com, and you are free to contact me anytime you want for your queries and questions. And thank you all. And then I have to mention the next event of no-code community, how to create a high-performing team. And I should maybe give the microphone to Yara.
Thank you, Murat. Thank you very much for this webinar. I received many notes and comments, like everyone was taking notes. They were super interested in this webinar. And our next workshop will be an online workshop on how to create high-performing teams on remote. That was in partnership with the SBIC, so with the Space Business Innovation Center in Norway. And due to the COVID-19 crisis, we are moving this workshop online. And we reduced the price to 60% discount because this reason. So thank you very much all. I will send you the recording of the webinar with the notes and the link to all of you in the Collabwith community, because we have a chat. Like you can chat with Murat on real time inside the platform.
Yes. I'm available, and once again, thanks to Yara for giving us opportunity and might be a very interesting subject.